All right, so continuing on with what we've been doing, this should not feel like it's new, but we are going to go over it just like it is new. Remember our unit circle, and it says, suppose that the angle formed by a segment and the positive x-axis is the unit of 52 degrees. So on our unit circle, remember that a halfway would be like a 45 degrees, so 52 is a little bit more. Doesn't have to be exact, but that's about what we're talking about. They want to know the coordinates of this point C. What is, class, your x value? What is that? Is that sine or cosine? Cosine. So it's going to be cosine of 52. And then our y value is going to be sine of 52. Yes?
So wait, if the x value is, so how do you figure out if it's cosine or sine?
Cosine, the x value is always cosine, the y value is always sine, and the nice thing about it is just like x comma y, see how, you can go. See how this is alphabetical?
Yeah.
This is alphabetical. And it's always cosine, then sine. Does that make sense? Okay. So it says we are going to do it to the nearest thousand. So in our calculator, we're going to do cosine of 52. And we, to the nearest thousand, so then we have a 0.6, 1, and 6. And I want you guys to store this in, we're going to store it in A, and I'll tell you why in a little bit. But I want you to store it in A. Then the other one, we have your sine of 52. So we're going to go sine of 52. And that is 7.88. 0.788. And we're going to store this in B. All right. So the point on this right here is right here. That point is 0.6 and this comma 0.8, right? I will tell you the unit circle, I want you to kind of, when you're doing the decimals, kind of watch what it is because it's going to help you when we graph to kind of remember to think about. It's always going to be your less between your -1 and 1 when you have it out in decimals. It's always going to be that because that's cosine and sine is, yes. So the store is down here right above the on. It says store. So you hit the store and then you do like your alpha. So I would go store and then alpha B. Say it again. It doesn't, but I'm going to be saying the letters in a little bit, so you'll just have to remember what letter you used. But were you able to store it? Okay. All right. So now it says to use the A to show that this point satisfies the Pythagorean identity. So if we were to drop that, where they're going like this is kind of what they're doing, and they want us to prove that this uses that Pythagorean identity. It's on that unit circle. What is the Pythagorean theorem? If you know it, say it out loud. So a squared plus b squared is equal to c squared. So we have 0.616 squared. Yes. And we have b is 0.788 squared and equals C. On the unit circle, what is our radius at all times? 1. And that's why it's called the identity. So 1 squared, which will give us 1. So in our calculators, now we can just say a squared plus b squared to find out what that is. So a squared plus b squared, and that equals 1. And 1 squared is also 1. If you put these in here, it's going to give you approximately 1, but since we stored it, it gave us exactly 1. Does that make sense? And that's why I wanted to store it as far as that goes. Questions? All right. 135. Exactly. We're going to find sine of 135 exactly. What does the word exactly mean? No decimals. It also means that it's probably going to use 30-60 or 45-45. Or be on one of these, because that's on one of the legs. Alright. So, sine of 135. We have, this is 90. 135 is going to be in this quadrant. Where do I drop my other leg? Do I put it to the x-axis or to the y-axis? X. Very good. How do I find this angle, this reference? This is called a reference angle. How do I find that reference angle? So we're going to do 180 minus 135. So we got a 45. So this is a 45. Take just a few seconds to write the angles, or not the angles, the legs down, the sides down. What are they? Check to see if any of them are positive or negative. Alright, so let's go with our, just the numbers. What's this number? We're just going to do the number. So 1, 1, and then square root of 2. Remember, this 1 is representing the x-axis. At this point, is this x-axis positive or negative? Negative. This is my y-axis, so this is positive. Right? Another thing to kind of think about is, remember, it's cosine and sine, right? So in this quadrant, cosine is my x's. Is cosine going to be positive or negative in this quadrant? Is your x's positive or negative? Negative. So cosine's negative in here. And sines are going to be my y. My sine in this quadrant is positive. You should be able to look at the quadrants eventually and tell, I should be able to say, is sine positive or negative in this? And you should be able to tell me by looking at your x's and y's. Alright, so we have Sally could tell Oscar had a hat on always. So sine of 135 is opposite over hypotenuse. So opposite over hypotenuse. Am I done? Oh, go ahead.
How is it that we use 135 there instead of 45?
Because remember, this is this angle right here. But to be able to use our special triangles, we have to find our reference angle. 45 degrees is really in this quadrant. Where's 45? Like in your circle, where's 45? 45 would be over here.
Because we start at the top.
You always start at, this is 0. So like this would be 45, this is 90, this is your 135, this is your 180, 270, 360, like when you go in a circle.
Okay.
So from here to here is your 135. From here to there. That's 135, the angle of 135. To find the sine or cosine, we have to use they're called reference triangles. Our reference this is our reference triangles to help us find them. So this right here is our reference angle, which is the 45. What makes it different is the fact that we have to figure out what is positive, what's negative.
Okay, so because it's kind of a weird triangle is why. Because it's a reference, it's not necessary. Maybe I should ask you about this after.
Yeah, maybe. I don't know. Yeah. We can talk more. Yeah. But we are still finding the sine of 135 because of where it's in the quadrant. That's what tells us if it's positive or negative on our sides. All right. So we must multiply both the top and bottom by the square root of 2. So our final answer is the square root of 2 over 2. To check your work, when you can use your calculator, put the sine of 135. And it's going to give you a decimal, and the decimal should be between 1 and -1, which it is. To see if it's the same thing, put this in your calculator and see if it's that. So square root of 2 divided by 2, which it's the same thing. This is your exact value. This is approximate. But it also helps you to check to see if you're right on positive, negative, things like that. All right. -120. Am I going up or am I going down? And we always start at 0. Am I going up or am I going down? Down. So I go -90, -110 or 120 is going to be right there. I need to find that reference angle. I'm finding the reference angle that's right here. So I take 180 and I subtract the 120. So I get a 60. You can do it however you want. I'm just going to do it the way I always do it. I always put my 30. I know next to the 30 is the square root of 3. Across from the 30 is my 1. My hypotenuse is a 2. That's how I have it memorized. Now we have to check what? Negatives, that's right. So are any of those negatives? What are negatives? Both of them are negatives, right? Because your x-axis is negative and your y-axis is negative. So that means in this quadrant, both my sine and my cosine are negative. Both your cosine and sine would be negative in that quadrant. All right. We are finding all 6 trig functions. I should have done that over here. That's right. All right. So we have, I'm going to bring it down. Ellie could tell. Always. So sine, and I'm just going to go sine of theta, which is the negative 120, is equal to opposite over hypotenuse. So opposite, negative square root of 3 over 2. So opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. So negative 1 over 2. Tangent of 120, but I'm still going to just write theta, just for space saver, is opposite over adjacent. Negative and negative will make a positive, so I have the square root of 3. Sine, what's the reciprocal of sine? Do we know? Maybe remember? So it's your cosecant, so CSC. I always remember S goes with C. So the cosecant of negative 120 is the reciprocal of this. So I got negative 2 over square root of 3. Have to multiply the top and bottom by square root of 3. So secant is negative 2 over 1, so it's negative 2. And tangent is with cotangent, which is 1 over the square root of 3. Can't have the square root on the bottom. So you multiply both top and bottom by that square root of 3. We are going to work for a little while, but later on this hour, or possibly tomorrow, depending upon what it is, we will be doing one more short paradox, but for right now,